During today's video, we're going to be covering the upcoming features that are going to be available in the next ExactFlat release. We're going to go through a full overview of the ExactFlat workflow, and we're going to use this car seat 3D model as an example file. To get started, we're going to transform our NURBS object into a mesh. Then we're going to create a new layer and call it mesh, and select our mesh that we just created and change the object layer hide out the original surface that we had. So now that we have our mesh model here, we're going to explode it and join back the pieces that should become single pattern pieces on their own. Now that we have joined our pieces, we're going to select our mesh model and weld it. Leave an angle tolerance of 180 and hit enter to confirm. So now that our mesh model is ready, we're going to duplicate our mesh layer and call it adaptive Remesher. And this is just for keeping our model organized. So I'm going to switch to the new layer that we just created and leave the old mesh layer as a backup. Then I'm going to go to the ExactFlat mesh tools and use the adaptive Remesher so we can transform this mesh into a more efficient mesh that we can work with. I'm going to start the Remesher, hit OK button to confirm. And now we can get started with the flattening side. So I'm going to go to my tools, select the ExactFlat flatten command, select our mesh and hit enter. So we can see now that we just created two new layers. So one is going to contain the ExactFlat model and the other one is going to contain the ExactFlat pattern. I'm going to switch to ExactFlat pattern layer and hide out the original mesh that we had. Then we can switch to the top view. So now we can select our ExactFlat patterns and move them aside. When flattening our pieces, now we can see a preview of our seam allowances that are going to be offsetted from the pattern boundary edges. The default offset distance can be set up under the ExactFlat patterning options. So now that we just started with the flattening process, we're going to move forward and optimize our pieces normally. So I'm going to pre-flatten them. So now that we pre-flattened our pieces, we can use the optimizer. So I'm going to select all of my pieces, and we'll see now that when optimizing our pieces, now ExactFlat supports a multi-threaded optimization, which means that our workstation processor can optimize several pieces at the same time, depending on the amount of threads that your processor can handle. So I'm going to hit enter, select a cotton material as a default, and hit OK to confirm. So now we can see that all of our pieces are being optimized at the same time, and that's performing much faster than with our previous optimizer. We can also see that our accuracy report chart has been optimized as well. So now we can have a much cleaner view of what's going on with our pattern pieces. So we can see now the average energy density levels being displayed in Newton meters and with a percentage number as well. Then we can see that instead of a no seam stretch error, now we can see a pattern perimeter length deviation over here, a pattern surface area deviation, greatest elongation, worst sag, and the minimum and maximum energy density levels, and our vertex count and triangle count. That way, we can follow up our pattern piece behavior more concisely. So now that we have finished processing our flat patterns, we can hit the OK button to confirm. So now we can start applying some post-processing features. So I'm going to select my main part over here, and I'm going to rotate it with our regular Rhino commands. Turn on my vertex steps. And we can use the Find tool for placing our neighboring pieces. So now that we have organized our meshes, we can take a closer look at our pattern boundaries and our seam allowances. If we zoom in, over here, we can see that we have some blue dots at our pattern boundaries, and these blue dots are marking the edge split points that are going to help us define independent seam allowances. So if we run the command ExactFlat set pattern edge properties, we are going to be able to set up our seam allowances with different features that are going to simplify our workflow downstream. So first of all, we can see that over here we have an offset distance. If we click on the offset button, we can set up the offset distance that we want to set up on that edge. So for example, I could be setting this one up to be 5 millimeters. And then we can see our start and end conditions. Our start and end conditions are going to change the way in which the seam allowance is interacting with the corners or our split points. So for example, if we take this piece and we set our start condition to none and our end condition to none, and our offset distance to 5, by clicking on this, we will have now this seam allowance set to 5 millimeters, and the none start and end conditions are going to set up these two split points to have this 90-degree edge start from the last boundary edge. If we change our start condition, that's going to change the condition for the split point that's located clockwise to the edge. And if we change the end condition is going to set up the condition for the split point that's located counterclockwise to the edge. So in this case, if we change the start condition to trim extend instead, and select this edge again, that's going to extend both meeting seam allowances until they connect to each other. If we change our start condition to chamfer angle, then we are going to be able to set up an angle that's going to start at the edge of the starting polygon of the seam line. So right now my start condition angle is set to 45. We're going to leave that for now, and if we select this edge, these two are going to have a 45-degree angle from both edges. But if we change the start condition angle to 60 degrees, then that's going to change the condition angle for the starting split point. Then we can see that we have the chamfer neighbor option. The chamfer neighbor option is going to create a line that will let us fold our seam allowances. So once folded, our seam allowance will match the pattern edges. So I'm going to select this edge. So it's very likely that we are going to see a greater difference if we have a greater angle. So I'm going to select this piece instead. So we can keep on applying our start and end condition. So now we can see that if we folded this edge over this part, this edge should be touching this one, and this one should be touching this one instead. So we could choose different start and end conditions. So that way, if we select an edge, that will be applied to both ends at the same time. And then we will have our geometry profile. So we can change this to line if we want our seam allowance to become perfectly straight. So if we select this one, now this will apply a start condition of chamfer neighbor on the starting split point. The end condition is going to apply trim extend on the end point, and the geometry profile is going to transform this curve into a straight line. So if we select this edge, that will transform it into a straight line instead. If we wanted to add or remove some blue dots, we could be using the ExactFlat merge pattern edge command for removing the split points that we don't want to have. We could also add more split points if needed by using the ExactFlat split pattern edge command. So that way we could be adding a split point over there, and now with the ExactFlat set pattern edge properties, we could be changing the seam allowance for this portion of the edge individually. So we can change the offset distance to something like 10 and apply it, and don't forget to change the geometry profile as required. In this case, we may likely use a chamfer angle for setting that one up. Then if we wanted to restore our piece back to default, we could run the command ExactFlat restore default pattern edges command. And if we select our piece and hit enter, this will restore our piece back to its initial piece configuration. And the seam allowance that we will see will be the seam allowance that's been set up within the ExactFlat global settings. If by the contrary, we wanted to remove all of our edge split points, we could be running the command ExactFlat delete all pattern edges. By running this command and selecting a piece, that will not only remove our split points, but that will remove our seam allowances as well. So from that point, we could start adding more split points as required. If we wanted to save up some time when applying our split points, we could also run the ExactFlat split pattern edge break angle command. And by setting up a break angle, that will let us automatically apply some split points on our pieces. So for example, if I leave this break angle at 40 and I select my piece and hit enter, that will detect wherever we have a break angle of 40 degrees or more and apply a split point there. So now that they are applied, we could start applying some seam allowances on each edge. So on this one, I could be selecting a trim extend condition for all of my start and ends. And I could change the offset distance to 30 on this edge and 10 for the other edges. On this corner, we can see that they do not perfectly match. So in that case, it may be better to use an end condition of chamfer angle, and that should fix it. So now that we have finished up setting our seam allowances, so now for example, I could be fixing up this part by, in this case, running the ExactFlat delete all pattern edges. and add some automated split points. And in this case, we could be applying some more splits over here. By default, our ExactFlat edge splits are going to be applied wherever ExactFlat detects that you have sewing line. In this case, in this example, ExactFlat was detecting different sewing lines because of the way in which this model was originally set up. So now that we have applied our edge splits, we can continue setting up our seam allowances accordingly. In this case, we could set up and trim a start condition of chamfer angle and an end condition of chamfer angle as well, and set both to 45 degrees. In this case, we can change the offset distance for the ones at the top. So now that we've finished up placing our seam allowances, we can move on and apply some notches and piece tags. So if we go to the piece tag dialog box and we leave this value by default, that's going to automatically number our pieces accordingly. Now that we have applied our piece tags, we can move forward and apply some notches as well. I'm going to be applying some I-type notches on this side and some B-type notches on the other side. Last, we could apply some tracings if needed. So we could go back to our 3D model, draw a simple spline, which could be marking the location of a Velcro. So I'm going to use the ExactFlat trace tool for applying a trace line. And now that it has been flattened, we could move forward and start setting up our exporting profiles. So in the upcoming release of ExactFlat, we are now going to be able to set up different export profiles. So depending on the cutting machine that you are using, you are going to be able to fully customize the way in which your files are going to be organized. So if we run the command ExactFlat export profile editor, this will let us select between the different export profiles that will come with ExactFlat. So if the cutting machine that we wanted to use was not within this list, we could be adding our own profiles, or we could be starting from an existing profile and copy it. So that way we could be changing some features that were already set up in the profile that we are selecting. In this case, I'm just going to be adding a new profile. And in this new export profile that we will have over here, let's name it new profile 01. We will be able to choose between grouping our pieces or exporting them ungrouped. If we enable the group pieces command, that will let us export our pieces either grouped or into blocks, depending on the file format that we end up selecting. Now I'm going to select group pieces, and over here, under geometry type, we will be able to select between the different entities that are going to form our final DXFs. So in this case, I'm going to be selecting splines, and down below, we are going to be able to place each one of our features into layers, and we are going to be able to name our layers however we want to. So for example, in this case, I could be calling this one seam lines. Then for cuts, we could call this one cut. We could be calling our grain lines grain. Then we could be calling our piece tag, well, piece tags, and so on. So let's continue naming our pieces. So now that we have named our layers, we are going to be able to change their colors as well. So for our seams, I am going to be choosing a blue color. For our cut lines, we're going to be using a red color instead. Our grain lines could be having this orange color. Our piece tags are going to have green color instead. And our notch tags as well. This way, these features are going to go to the same layer. Our notch lines may go to the cyan layer instead, so our notches are going to go to our cyan layer. And our trace lines could go into the black layer. Then we can choose which layers we want to be exported and which layers we don't want to be exported into our final DXF file. So now that we have customized our profile, we can close the ExactFlat profile editor, save our changes, and now if we run the ExactFlat export command, we will be able to find our newest profile. So that way we can just place our file on our desktop. And export our final AutoCAD DXF. In the upcoming ExactFlat release, we will also be able to select between DXF, PDF, and 3DF formats. So let's create a few files over here. And let's export one page. So now we can import back our exported profile. So now that I have imported my profile, we can see that within the DXF file that I have just imported, all of our features are going to be organized into separate layers. So this way, you could be assigning different tools of your cutting machines for performing different operations. So let's take a quick look at the other profiles that we exported, as we will also have available a PDF file and the Rhino 3DM file as well.